Let's begin. Find the area of the part of the cone. Can you help in solving this? The area. No, be careful. This is area of the part of the cone. This is the equation of the cone given. This is the equation of the cone. We're familiar with it now. We dealt with it the last revisions. Many terms. You can use orders. You can use this to find the volume of the cone and related to the cone. Here, the question is different from the last time. This is area or part of the cone. Remember this formula. Okay, let's begin. What is the sketch of this graph? This cone, if you put Z0 in this equation, you get the origin. If you put Z equals 1 or 2, you got a small circle. And you get the circle here and there. So,
Doctor, I can't hear you.
okay, this is the cone. You see it now?
Yes.
Okay. The given cone. Cone, you can draw some surface here, the lateral surface of the cone, and there is one behind as well in all directions. So we need to find this equation 2 root x squared plus y squared. This may be replaced with the equation of a sphere, paraboloid, whatever surface. If you check the answer sheet,
Doctor, I can't hear you well.
you don't see or you don't hear? Sorry.
كده تمام.
So what is the formula? We only this was an application of double integration, if you remember. What was the area of this part of the surface? He gives you, he asks of which area, of which part of the lateral area, the area exactly above the triangle between these points 0, 0, 0 or O, 5. This is the point A, 5, 0, 0. Then the point 3, 4. This is the point 3, 4, 0. And the origin. So we need the area on this lateral surface of the cone exactly above this region A. This is the region A. How to find this? Any idea?
Double integration.
Yes. Area.
ما-
Double integration. Yes. Over A.
أوصل الإيكويشن بقى اللي هي x root x squared plus y squared.
Or call it R as usual. Let's call it R as usual. And here integration over R. Over the region R. The region R is the given triangle. Go on. Tell me the rest of the formula.
2 root x squared
No
plus
2.
y squared.
Only root. Square root of?
X squared plus y squared.
No. It's 1 plus fx squared plus fy squared. TA. What is this? This is partial z partial x squared. This is partial z partial y squared. Got it?
Okay.
Okay. So we need to prepare all of this. It's direct, I think. So we can do it together. Z is 2 square root of x squared plus y squared gives partial z partial x equals, this is 2. The derivative of the square root is 1 or double the square root times here the derivative, what is inside the square root? 2x.
2x.
And simplify this to get this to cancel, to get 2x over the square root. Similarly, we have the same for the y, 2x over the square root of x squared plus y squared. Similarly, partial z partial y is 2y over, because it's symmetric. Okay, so now let's simplify what is inside the radicand, the radical sign. So 1 plus fx squared plus fy squared is 1 plus square this quantity to get what? 4x squared
4x
over
squared over x
without the
squared plus
square
y
root.
squared.
Same for y. 4y squared over x squared plus y squared. Therefore, we can unify the denominator, common denominator, x squared plus y squared. You get 1 here, x squared plus y squared. You get here what?
Times 4.
4x squared plus 4y squared. It is the same common denominator here. Just we need to put it here with the 1. You can do it another way if you add these derivatives first and then add the 1.
Okay.
Okay, it will be easier. So this is the 1, and this is x squared plus y squared. Because this will cancel, because taking the common factor, 1, will give you 4. 1 plus 4, which is 5. That's it. What is inside the radical is 5. So therefore, we have this lateral area equals over the region R, the square root of 5 dA. What is A? A is this triangle. A is this triangle in space. It is in XY plane. You can draw it here in XY direction at only. This will be enough.
Okay. So هنا we'll need to بقى تبقى السلوب وكده ولا لا؟
طيب, let's do it. Therefore, we get root 5 dA. What is this? What is this summa? We don't need to find the equations of the lines or anything. This is the area of the triangle, isn't it? So this is 1 dA. 1 dA is the area. Area of what? If it is an area of square or rectangle or circle, something I know the formula of, I can apply it directly. So times the area of the triangle, which is
base times height.
Yes, exactly. This is the base, which is 5. This is the height, which is 4. So it's a half times 5 times 4. So it's something like this is 2. We get 50 units of area. Most of the people didn't solve this question. Why? Because they missed this topic or mixed it with another topic.
Okay.
So this is part of the surface area of a given surface in space. We have this topic as an application of double integration. What it says, it's a long formula. Yes, it's a long formula, but the application is easy. And sometimes the integration comes very difficult and you are asked not to try to calculate it or approximate it using the calculator. So the thing is to recall the formula or to read it from your formula sheet, do the derivatives, the squaring, the simplification, and the integral will be easy or hard as as usual. Anything here is not clear?
لا تمام.
Okay, you can do this with other shapes, paraboloid. We have a special worksheet about this as an application. The final application of double integration was this special section is devoted to this. There was another question from another student. This question was about limits and continuity, how to answer it. He gives you a function defined by two steps or two formulas. For all points in the xy plane, it is defined this way, xy squared divided by this quantity power 3 over 2. Away from 0. But at 0, it is 0. Determine the set of points at which the function is continuous. How to answer this, we need to find the domain first. The domain is here. We need this not to be 0. Yes. When this is 0, the denominator, this denominator is 0 when x squared plus y squared is 0. And this happens only when x and y is 0, 0. So the only point here, the function at which is not defined by this rule is the point 0, 0. And this is the case. But at 0, 0, we use this formula. This use the second formula. So domain of function, domain of f is R2, all of R2, or you can write it R cross R. We can do it this way, all of the domain, all of the plane. XY, all of the, nothing wrong with this, with these points on the plane. The second thing, is a function defined at 0, 0? Yes, it is in the domain, so the function is defined. And the first point is f0, 0 is 0 defined. If the function is not defined, means the point is not in the domain, it's surely not continuous at the point. Now the important and the long bit is to find the limit of f of x. When xy approaches 0, 0. If this limit exists and equals 0, therefore the function is continuous at 0, 0. If this limit exists and not equal to 0, it's not continuous. If this limit does not exist, for sure the function will not be continuous. So now we need only to to compute this limit. What do you think?
when we plug in هتبقى equal 0.
How to prove, how to verify this, your claim or your guess?
Unplug 0.
Yes.
Unplug 0 في equation اللي هي
Unplug
x y
0 بس
squared.
هيطلع 0 على 0. This is not defined. This is not enough. We need to go some way. You know, we have many.
ممكن نعمل l'hopital.
If we have one variable, we can do l'hopital. But we have two variables, so we can approach the point 0, 0 from different directions. But this is not a proof. We can change into polar, if you like. You can go through the x-axis. If you approach through the x-axis, let's have a guess. Let's try the x-axis where y is 0. When y is 0, you put y 0 here, so you get the numerator 0, and the denominator is x cubed. So when x tends to 0, and the numerator is 0, so we have no result. It's undetermined quantity. I think the same will happen the other direction, on the y direction, the y-axis. Put x is 0, we get the same situation. We can try the line y equals mx, which passes through the origin, whether this depends on m or not. If it depends on m, so it varies from a line to another. This is another method. But I think the idea here is when you have x squared plus y squared, you can check what? You remember?
Yeah.
What do we use when we have x squared plus y squared sometimes, or square root of x squared plus y squared? I think it's polar. Yes?
R squared.
This is a clue for polar. Yes, this is a clue for polar. When you have x squared plus y squared, it's r squared. So we can go for polar transformation, polar quantities, polar coordinate system. Change into go to polar coordinate system, which is r and theta, where x equals r cosine theta and y is r sine theta. And from this, x squared plus y squared will be r squared. And this will be enough, I think. Let's try this. Limit. What you get here?
R cosine theta
R
times
cosine theta.
R sine theta squared.
Yes, r sine theta squared. Here we have r squared to the power 3 over 2. When xy tends to 0, 0, when xy approaches this point, means r approaches 0. But theta can vary. We cannot say theta tends to 0 because theta goes in all directions from theta 0 into 2 pi. Let's check r whether it will depend on theta or not. Let us calculate this limit when r tends to 0. This is r cubed, yes?
Yes.
Cosine theta,
Sine theta squared.
Sine squared theta. Here we have r cubed. So it does not depend on r.
Yes, it cancels.
So what is the result?
It depends on theta.
Yes, it depends on theta. So limit equals cosine theta sine squared theta. In fact, when theta is 0, we get 0 because sine 0 is 0. When theta is pi, over 2, we get 0 because cosine pi over is 0. But for different values, for other values, it will differ. So it depends on, you can calculate it. It depends on theta. For example, when theta is pi over 6, 30 degrees, it approaches what? Root 3 over 2, here half square, which is root 3 over 8. When theta is pi over 3, which is 60 degrees, limit approaches what? 60 degrees. This is half. This is root 3 over 2 squared. This gives you 3 over 2 times 4 is 8. It's totally different. This is an example. If this is the case, this means we could solve it using y equals mx. There is another solution for it. So anyway, the limit depends on theta, means when theta is pi over 3, the line having sloping the angle theta is 30 degrees will give a different limit from the line having theta equals 60 degrees. Therefore, what? The conclusion, this limit what?
Does not exist.
What is the value of this limit? Yes, does not exist. Does not exist. You may try y equals mx. What is y equals mx? This line. Having angle theta, this is x-axis, y-axis. Here theta is 0, here theta is pi over 2. But they didn't show, they didn't verify the inequality between the x and y-axis, but other lines show that. Okay, if it depend, it would depend on m, but sometimes this polar transformation makes it easier. What is the final answer? Because we didn't answer this question. He didn't ask me about the limit. He asked me about the points of continuity. What to say? How to answer now? Not to miss any point. Yes, the limit does not exist at 0, 0. Therefore, it is not continuous at 0, 0. Yes?
Oh, yes.
Other
But
points,
it's continuous on any other points except
in all
0,
other
0.
points. And to verify this, we need to explain a little bit, because it is formed of the variables x and y, polynomial functions in the numerator, polynomial function in the denominator, and square root and cubing, and these powers and this division. This is the basic operations. It is formed from the variables x and y with the basic operations of multiplication, and division, addition, multiplication, squaring, cubing, square root. All of these operations bring or form continuous functions, except at the points the function is not defined at, which is 0, 0 here. So we checked it separately. We checked the point 0, 0 alone. Otherwise, this theorem proves this function is continuous everywhere, except for the point 0, 0. It needed some special study. You need to say this stuff because it's a theorem. He sometimes asks about this sort of theorem, to use it carefully. So how the answer now? So the answer to the question, after studying this, f is continuous everywhere on R2 except for the point 0, 0, as it is formed from x, y with basic operations. What are these basic operations? Plus, minus, multiplication, division, power, square root, nth root, and so on. If you do, we have a theorem. According to our theorem, this produces a continuous function, except the points at which the function is not defined, or the limit does not exist, as we proved here. That's it. Any question, Sama? You need to do the YMX, or this is enough for you?
Okay.
Okay, you try it yourself.
Okay.
Do you have any other question?
لا تمام.
Okay. Here is another question about this function, this same function. He asks you to find the partial derivative with respect to y at the point 1, 0. For this function, This is part A, part B. Calculate the partial derivative of f with respect to y at the point 1 and 0. How to do this? This sort of question about the derivative at a specific point, we need to use the definition. Okay, we are away from the point now, a point of discontinuity. We can use the derivative directly. We can make direct. Okay, let's copy this, because at 1, 0, this is the function. Or we can go to the derivative, the definition. This is f, since f of x, y equals this. How to find this partial derivative? Let's go on Sama.
And first is هنجيب هتبقى 2xy over
Yes. What rule do you use?
differentiate عادي بس x
Yes.
تبقى constant.
Yes, and then consider x as a constant, exactly. And then what we have here, it's a quotient rule.
Okay.
Yes, you consider, as you said, consider x as a constant. And use or apply quotient rule of differentiation. So let's have, this is partial f partial y equals the denominator x squared plus y squared to the power 3 over 2 times the derivative of the numerator, as you said it,
2xy.
okay. 2xy, yes,
minus
minus
xy
xy squared, the numerators times
3 over
times the derivative
2
of the denominator. Yes.
3 over 2 x squared plus y
y squared power half.
Times 2x.
Yes. I dropped the power and decreased it by 1. Then derivative of what is inside the bracket?
2x.
2x or 2y? What we differentiating with here with respect to what?
2y, sorry.
2y. We
2y.
consider y the variable.
Okay.
Okay. What else?
The denominator squared.
Yes, denominator square will be power 3. We don't need to simplify it. We need to substitute directly. Before that, let's cancel these 2's. This will be enough. This power half is a square root. This is power 1 times the square root. Anyway, let's substitute. Substitute what? Therefore, partial f partial y at 1, 0, or of 1, 0. This is the two notations we have. Any one of them will give you the same story. Here we have x is 1 and y is 0. This means put x, plug in x equals 1, y equals 0. Plug in these values. Therefore, you can directly guess what is going on. Here we have 0 because y is 0. Y is 0, so the product is 0. Here as well, again, y is 0. This is 0 as well. The denominator will be 1 plus 0 power 3. So we have 0 in the numerator over 1, which is 0. We don't need to simplify this because he asks about a specific value. We found it directly. These are the questions I got from your colleagues.